Okay, so just to recap for everybody else who's jumping in, so we started off with what? Can you kind of like catch everybody up onto what we did so far in the math, where we're at now?
Got it. So we are currently solving for the first part. The number q of units that produces maximum profit is q equals blank. So we've been taking the two functions that they've given us and trying to apply it to find an equation for the profit. And to find the profit, you would need to find the total revenue and then subtract the cost from it to find the profit. And then breaking down revenue minus cost, that would take us back to the functions that are given, and then also figuring out what makes revenue. And revenue is the price of a product that is sold times the quantity of how many of those products were sold. So then revenue equals P times Q, and they give us P in the given function. So then it becomes plugging in as many aspects of the given functions into our profit function. So then we have our P equals 77 minus 2Q come down to be multiplied by Q to make up revenue, subtracting cost, which is a given function from the problem, which is 90 plus 13Q, and then multiplying it out and simplifying it. And now we have a profit equation, and now we're to figure out how does that help us find the answer to the first problem.
Okay, great. So now the interesting thing about this point forward, with this problem specifically, we're going to first approach it with calculus, because obviously that's what we're practicing, but you can actually solve this even just with algebra. And I'll show you that one, but that one again requires some insight. So the way that we're kind of looking at this problem now is now we need to start to be creative. We want to find a maximum profit. We know that we have this function. This is where we don't always necessarily have like a set of procedures. There's one that was taught in this class, but at this point you also have permission to be creative. So here's an interesting one that I like to think of. What is the shape of this graph?
This would be a narrow upside down U. It's a parabola.
Right, parabola, perfect. So even if we don't know where it is, so I'll take off like this y-axis, we don't know like where this is sideways wise, we know it's definitely going to be this shape. And that already starts to give us a picture that captures the idea, right? There's going to be a maximum.
Mm-hmm.
So that's one thing that helps us out a little bit. We were talking, let's see, do you remember any of the steps from kind of this section where it was talking about how to find those maximums? Or anything that this picture kind of sparks in terms of what you've learned so far?
So this is usually the point where, I mean, since it's a parabola facing downward, finding the vertex would probably be finding the maximum, or do some good old calculus.
Good. That's exactly right. Those are your two approaches, right? So if you want, we'll do the calculus one first just to keep in the vein of the course, but you could also have just found this by the vertex. So how do you know how to do it with the calculus, or do you want to review that?
Let's review it so I make sure I've been doing it right.
Okay, so then the first thing I would ask is, like, there's really only two so far, and I don't think you all get to the third one. There's only two big topics you've learned so far in the course. One was limits. Limits is the logic of approach. Do you remember what the second big one was?
Is that referring to derivatives?
Derivatives. What is a derivative?
So, derivative is I don't want to say just taking a prime of a function, because that's not the definition.
Yeah, that's the method, right?
Right.
Right. In the same way where it's like people say power rule, and it's like power rule isn't a derivative. Power rule is a thing you use to find a derivative if it's appropriate.
Mm.
The easiest way to think of a derivative is that it is change at a moment. At a moment change.
Oh, right, because it, like, you use it to find instantaneous velocity.
Yep, you can find it if you're
that
talking about
moment.
where things are. Yep, in the terms of a graph, you can find it with its slope, right? That's another way of saying it's a slope at a point, which is the same thing as where that graph is traveling at a moment. There's a lot of different applications for it, which is why it's so powerful. In this situation, do you see any place where the derivative may be interesting?
In finding the instantaneous slope for the maximum profit.
So like if I was going to draw the derivative on this picture, where would be interesting to draw it?
Oh, wait. So would we be taking the derivative and then having that equal to 0?
Good.
Because
So that's exactly what the way to think about it. So if we think of a derivative as an instantaneous, yep.
Yeah.
If we think of a derivative as an instantaneous change, a way that we can see change at an instant is by a tangent line. Tangent line for this situation be very interesting right here. And here, the tangent line slope is 0. All of that comes back to the logic of being like, okay, if I would like to find a maximum, or in some other cases, minimums, or in some other cases, just moments where I've paused in my growth or kind of depth, we are going to find the derivative and set it equal to 0. So let's go ahead and walk this one through. So I've got profit. Let's do profit
Prime.
Walk me through that.
Alrighty. So you would bring the squared exponent to the front, so it's negative 4q plus 16.
Now, why did you do that? What's the method that allows us to do that?
What's that rule called? It's not chain rule,
Nope.
right? Nope. It's not product. It's not quotient.
Think about what you're playing with. What'd you play with?
Exponents?
Yeah. That's why it's the power rule. It's literally
The
playing
power
with the
rule.
powers.
There.
Yep. Good. All right. So power rule allows you to do polynomials real easy. So the first part is definitely polynomial looking. The second part, 64. Good. And then the last part.
Making it equal 0.
Okay, good. Yeah, the negative 90 becomes 0.
0.
Because it's a constant, and if we're constant and we're not changing, if we're not changing, our derivative is 0, because derivative means change and change is 0. Like, do you see how that all ties into the same model? Okay, good. So now with that, like you said, we can set that equal to 0. So we're going to figure out when is, like as a story, this says, when is the change in my profit 0? And I am going to be changing my profit by 0 if I'm either at the total tippy top or at the bottom. And here there's only a top, so that's going to be a nice easy one to solve. So what Q value causes my profit to stop changing for a moment?
So then you would subtract 64 over to the other side. So then you have negative 4q equals negative 64. Then divide out the negative 4. So then you have 6 equals negative 64 divided by negative 4, which is just 16.
Very good. Now, at this point, there would be steps that probably got taught to you in the lesson that say what you would want to do is you would want to say, okay, let's consider on the Q line, since that's really what this x-axis is, a Q axis. Let's consider on that Q axis the value of 16. We know that at this point it's a derivative of 0. Let's also consider what the derivative is before and after. And that'll give us an idea of what the picture looks like. So we could say, okay, let's look at any number before, like, I don't know, 10, and let's put 10 into the profit prime function. That'd be negative 40 plus 64 would be, I don't know, 24. Like, I'm choosing this as just any value before, since I know that everything before when it's 0 has to be something other than zeros, because we found all the zeros. It's right there. Are you following so far?
Yes.
It's kind of weird. Think about it like this. If I wanted to know how many people were in Illinois or Wisconsin at, like, I don't know, let's say 11 a.m. versus 3 p.m., I could either count all of the people at those times, or I could just look at who crossed the border. If I know where the border is, I can just watch the border, and the same thing is happening here. If I know that the function only stops changing here, And that's the only time where it's 0. Everything before it has to be all on one side of 0 or all on the other side of 0.
Mm-hmm.
So since this one's 24, that means everything over here has to be positive because it was with the side of the 24. And I could look at any number on the other side of the 16 quantity, and that would be, I don't know, like 20. And a little quick in our head math says that that's going to come out to a negative value. So even if we didn't recognize its parabola, even if we hadn't drawn it over here, we already get to see that on one side it was increasing, it had a momentary stop, and then afterwards it was decreasing. Like, this is how we get into the curve sketching, is we get an idea of what the behavior is doing, and then we can kind of just make it curvy in between. Cool?
Yeah.
All right. And then lastly, we said, of course, since it's a parabola, we could have also just done all this with algebra, but that's only because we got lucky and it was a parabola. And we could have done that by, I like to find out where is the middle of this graph. And to do that, I like to just kind of find easy points that I can plot. So I like to find out, like, when does the graph have its x-intercepts? That would be, or in this case, q-intercepts. We could do something like, oh, I'm actually going to do it in reverse. Let's say that this is our profit. And then I could actually do like some weird algebra manipulation and do something like, this comes out to 32. And maybe if I'm just playing around with the numbers, I say, look, if Q is 0, then P, the profit, becomes negative 90. Tell me if you see that.
Because if Q is 0, then those would proceed to be 0.
Exactly. And similarly, if Q is 32, the profit is negative 90. This is one of my favorite ways to graph a parabola, because literally I can just plot the points 0, negative 90, and 32, negative 90. I know it goes downwards as a U shape, so that must mean that halfway between 32 and 0 is my maximum. Like, you don't even have to go, like, you just get to look at the equation, you get to turn the squared into something that looks much more approachable and then play from there. Or you could do the negative b over 2a formula that a lot of people learn in algebra. Like, there's lots of ways to
quadratic formula. That's all.
Yep, whole bunch of different ways. So that's exactly, but this is the calculus method over here. So this is kind of what they're teaching you now. But especially for tests, I like to have a way that I can double check it if possible. Cool. That was part A. Have an idea about part B?
Alrighty. So, woohoo. Alrighty. Now moving on to the second part. Okay. The price P per unit that produces maximum profit is P equals $blank.
So same situation, same scenario. This is just a continuation. We're trying to find price that makes this maximum.
So is this when we go back to when we had it P revenue minus cost P times Q minus 90 plus 13Q?
So what I think you're doing right now, which is super, super common, is you're kind of operating in the what am I supposed to do mindset, instead of just letting it naturally come from things you already know for sure.
Okay.
Okay. So what are we trying to find?
We're trying to find the price.
Price. Do we have anything here that describes price?
Where were you pointing at this point?
I'm not pointing anywhere. I'm asking you. Is there anything that describes price?
P.
Where? Which P? P where?
Within revenue.
P within revenue. Okay, so that P within okay, sure. So we're looking for the letter P, right? Do we see anything related to the letter P that we can pull on? Keep in mind, everything that we did over here was in pursuit of the first question. This is all part A, right?
Okay.
So using things over here, you could absolutely use it as a reference, but keep in mind that we went through this because I started by asking you, what does profit mean? And you gave me a whole story and we built logic around that.
Got it. So this
So
is
I'm now
starting.
going back and saying, okay, what is price in this situation?
Okay. Price is how much you charge for a product.
Very good. Do we have anything here that describes the price in our setup?
P equals 77 minus 2Q.
There it is, right? 77 minus 2Q. What this says as a story is that I can find the price if I know how many pieces I'm selling. Do we know how many pieces we're selling?
At the maximum profit is 16.
Exactly. So this one has zero calculus in it at all because we already have the information we need.
Right. So then 77 minus 2 times 16.
Very nice.
Which is 45.
Mm-hmm. Yeah, that's the other tough one, is a lot of people have difficulty trying to remember, like, okay, what's the proper technique for, and when do I use, and shouldn't I be like, and it's about, no, it's what do you want to use in the tool belt you've already built.
Okay.
Right?
Got it.
But it's all creativity from there. You could use graphs if it helps you see things. You can use algebra if you think it's appropriate. You can use calculus if you have a good storyline for it. Otherwise, like, it's all pulling it in as you want it. All right, we got the price.
And now the maximum profit.
All right, maximum profit.
Okay. So we don't necessarily. Oh wait. We have the formula that we made in the first part.
Exactly. We have something where we literally said, if I know the quantity, I can find the profit, right?
Mm-hmm.
Nice.
So big P equals -2Q squared plus 64Q minus 90. And then taking the Q from the first part, Q equals 16. Take that formula and then plug in 16 throughout the equation.
Very nicely done.
Equals 422. Oh, and it was written right there? Okay.
No, I was writing it as you were doing it, so.
Oh, okay.
Okay, good. So before you move on, so click on the X if you don't mind for a sec.
Sure.
So things from here that you just did. So absolutely, like, figured out the storyline, started to become comfortable. Do you see how, like, depending on what you want, you can grab at different pieces? Like, at minimum, you did not need this part that I have boxed if you had the graph. If you didn't have the graph, you did need this, because it would be the only thing that would help you recognize that you are at the tippy top, unless you recognized that it was a parabola. Then you wouldn't need either of them. Like, all of this is just brainstorming, putting down kind of tools and observations that you have and making a conclusion, almost more like science than math that some people do. But at this point that you've kind of got it, because you know that you're going to have more problems like it, it's up to you to not only kind of start to build your approach, but to start to make it foolproofed for future you to use on future tests. So start to choose the preferred method you like. And then, just like you said, when you kind of had those, oh yeah, moments, how can you make that something you recognize less in the future and just kind of have happen? Like, for me, I always lean towards a picture. And so when I see what's the maximum, I literally look back at the picture and then I remember how I graphed it, and then that gives me the clue that I needed. But some people like to label this and say, this is profit, and put the equation up there so that it's even more obvious. Like, you get to make these choices for you, so that when you're taking the test, the pencil's just running and your brain is already 3 steps ahead of it. Because it's a pattern at this point. It's just an approach that you've perfected. Cool?
Yeah.
All right, nice. Want to do another?
I mean, I am done with the homework.
Oh, okay. If that's it, then you're all good. Did you have other questions for me?
That was it in terms of this section. So,
Okay. Did you have other sections questions, or you just haven't gotten to them yet?
No, I'm good.
You
Currently.
good?